Hello, welcome back to Chapter 8, Section 2, Multiplying, Dividing Rational Expressions. Again, I think it's kind of funny that this is my 6th video for this, my 5th example, and only 2 of them involve multiplying and dividing. Okay, this one involves simplifying the rational expression as a step toward solving this as an equation. So I'm going to solve these equations. What I want to do is I want to find out what's the value of x that's going to make this equation true. So here's how I do this. I look at this part and I say, that looks familiar. X squared subtract 9 becomes x plus 3 times x subtract 3. That's the difference of 2 squares, and I factor it. The denominator is still x plus 3, and of course, for now, that's going to equal 7. Notice that the x plus 3 and the x plus 3, those are going to reduce, cancel, simplify. Again, pick your favorite word with that. I'm going to say simplify. So I'm going to draw a line through them, but just keep in mind that that's supposed to be x plus 3. All right, and actually it's there anyway, so I guess it's okay. So I get x subtract 3 equals 7. All of a sudden we're back in pre-algebra, and I get x equals 10. But now here's what I got to do. I got to take that number 10 and check it to see if it works. And the main idea is this. 10 plus 3 is 13. Okay, so that works. So you can check the rest of it. 10 to the second power is 100. 100 minus 9 is 81. 81 divided by 13 does equal 7. So that works. So I know that whenever we do problems where we check our solutions, like with the absolute value stuff, with the quadratic stuff, that there's some resistance. Hopefully people have been following directions. We'll see what happens. Okay, for this problem, I'm going to factor the numerator. What two numbers multiply to give negative 4, add to give positive 3. That's going to be x plus 4 times x subtract 1. By the way, if you're having a hard time factoring, chances are that's going to be one of the factors. The x subtract 1s are going to reduce, cancel. I get x plus 4 equals 5. And subtract 4 from both sides, I get x equals 1. Okay, good. Turn that in. Mr. Martin said check your work, but I'm not going to check my work. Guess what? That's wrong. Why is it wrong? Because if x equals 1, 1 subtract 1 equals 0. This is going to make the denominator equal 0. So this is no solution. There is no x that's going to make this true. Because when you find an x, which is 1, that could make it work, 1 subtract 1 equals 0, and that is undefined. So please check your work. Let's do a couple more here. What two numbers multiply to give negative 12 but add to give 1? That's going to be x plus 4, which looks like that, times x subtract 3. The x plus 4s are going to reduce, cancel, or whatever, simplify, sorry. Add 3, and I get x equals negative 4, but guess what? One more time, no solution. Dr. Berger likes to throw in a couple so that we can drive that point home, because negative 4 plus 4 equals 0, and you can't have 0 in the denominator. So I think hopefully you've got that through, right? For the last one, 4x squared subtract 9, that's a perfect square. Excuse me, the difference of two perfect squares. I get 2x plus 3, which is that, times 2x subtract 3, divided by the 2x plus 3 that I just mentioned, and that equals 5. The 2x plus 3 and 2x plus 3 are going to reduce, cancel, whatever. I'm going to add 3 to both sides. I get 2x equals 8. Again, I'm going fast because this is Algebra 1 pre-algebra. I get x equals 4. Now let's check. The main idea is, am I going to get 0? 2 times 4 is 8. 8 plus 3 equals 11. This one should be fine. So I can go ahead and check it. 4 times 16 is 64. 64 minus 9 is 55. 55 divided by 11 does equal 5. So that one does work. Check. All right. I'm going to do the guided practice problems in the next video. See ya.